Okay guys, so in this first video we're going to be taking a look at transformations of points using coordinate transformations. And in Algebra 2 you're really going to see two different types of transformation notation, one of which is going to be the coordinate transformations. And so those are happening to coordinates themselves, and they're fairly easy to detect and easy to see. The second one is really function transformation. So if we were to take a function such as this one, f of x equals 2x minus 3, transform that in some way, there's a way to represent that in terms of another function. But the first one that we're going to take a look at are the coordinate transformations. So taking a look at f of x equals 2x minus 3, let's first look to graph that function, and then we're going to apply some transformations to it. And in this video, we're going to really focus on the translations first. So taking a look at some x values, we'll take a look at some fairly standard x values, such as -2, -1, 0, 1, and 2. And we'll look to find the y values, or the f of x values, that are associated with those x values. So if we were to substitute in x values of -2 back into our function, so if we have f of -2, then that's going to be equal to 2 times -2 minus 3. And if we solve that real quick, 2 times -2 is -4. -4 minus 3 is going to give us a -7 there. Then if we take a look at -1, if we were to substitute that in, we would get a -5 back. Plug in 0, we'll get a -3. Plug in 1, we'll get a -1. And plug in 2, we're going to get a +1 out of that. So if we look to first graph those points, so -2, -7, -2, -1, 2, 3, 4, 5, 6, 7. Okay, and then if we take a look at the next point, -1, -5, and then 0, -3, and then 1, -1, and then 2, +1, we get a linear equation. And so if we go ahead and just draw a line for that first, and I'm going to cheat a little bit and use just a nice little line right there. Okay, so there's our line for 2x minus 3 equals f of x. Now if we look to transform that, and this is where it can get a little tricky sometimes, but we're going to look to first apply a translation, and we're going to go to the left 6 places. And if you remember what the word translation means, it really just means a shift. So we're going to be taking every point that's on our graph here, and we're going to be shifting it left 6 places. So if we just take a look at some of the points that we had, so if we start maybe at this point and we go left 1, 2, 3, 4, 5, 6, it'll end up here. And then if we go to this point, then it's going to end up here. And if we continue that in that same pattern, then we're going to get a very similar pattern to what we just saw, just in a different place on our graph. Okay, so if we graph all those points, and if we apply another line to that, just so that we can see that pretty clearly, okay, there's going to be our line. Okay, and that's going to be our new line shifted to the left 6 places. Now the notation behind this is important because we want to be able to represent every single point on this line and how it translated to the next line. And so if we take a look at just some simple points, if we take a look at that, maybe that first point that we translated, 2, 1, that was there, and see how that was transformed. Okay, so 2, 1, that became the point to the left 6 places. It became the point -4, 1. Okay, and you can see which values were actually changed and which values didn't change. And if we take a look at another point, maybe we take a look at 1, -1, that has now become the point -5, -1. Okay, we can start to see what the pattern is developing out of this. So if we take a look at just any points, if we say any point that's on there, and we'll label that as x, y, how did that change? And so every point that's on there, the y value is going to stay the same. The y value won't change because we just went to the left, and so it's affecting the x value. But every x value went down by 6 places. And that's really what we're getting at when we deal with function, or we deal with the coordinate transformations, is we're saying that every point that's there, okay, every point that's there, x, y, is changing in some way to get to the next one. In our next video, we'll take a look at reflections, and we'll take a look at some of the stretching that can take place in both the x and the y direction.